Hello there and welcome to Lower 6th Further Maths A-Level Pure Core 1 past paper June 2013. Here we're looking at question 1, which is new to Pure Core 1. It's that Polynomials chapter of questions. So here, let's just write down those formulas to start with. I'm working up to cubics. So the sum of all of the roots equals minus b over a. The sum of two of my roots multiplied together in all of the different combinations will equal c over a, and in the case here I've got cubics, all three of my roots multiplied together will equal minus d over a. Now what this refers to is this number 2 is a, the minus 9 is b, k is the value c, and d is the number minus 13. And these are my three roots, gamma, alpha and beta, where gamma we've already got as a half. So what we're going to do first is try and find those extra roots, alpha and beta. And to do this I'm going to be using two of my three formulas. And I've seen here that I've got a value for b, so I'm probably going to use that. Haven't got a value for c, so I'll leave that one now. And I have a value for d as well, so I'll use that one as well. So it's this one and this one of my formulas I'm going to use. So add all the roots together and you get minus b over 8. So plus a half plus alpha plus beta equals minus b. B was minus 9, so it would be a plus 9 over a. A was the value 2. And then if I take away a half from both sides, I'll get a alpha plus beta. 4 over 5, take away 1 over 2, that gets me to 4. And then if I multiply all of my roots together, a half times alpha times beta, I get minus d. D is minus 13, so that will get me a 13 over a, which is 2. So now if I times both sides by 2, I get alpha beta equals 13. So these two here are going to be my simultaneous equations I'm going to use to solve this question. So what I'll do is I will rearrange the first one to get alpha equals 4 minus beta and substitute it into the second one. 4 minus beta times beta equals 13. 4 beta minus beta squared equals 13. Beta squared minus 4 beta plus 13 equals 0. Okay, I don't see any way of putting this into two brackets nice and quickly, so I'm probably going to have to complete the square or solve it using the quadratic formula. Beta minus 2 squared, take away 4, add 13 will leave me with plus 9 equals 0. Beta minus 2 equals squared equals minus 9. Now square rooting here, it looks like I'm going to be square rooting minus 9. The only way I can square root minus 9 is to move into imaginary numbers. So beta minus 2 equals the square root of minus 9, and it's going to be positive and negative from there. Now the square root of 9 is 3, and the square root of I is square root of minus 1 is I. So I'm going to split them up into square roots such like that. So beta minus 2 equals plus or minus 3i. So from here I get beta equals 2 plus or minus 3i. Now it should be the case that no matter which value I use as beta, when I do 4 minus beta, I'm going to end up at the complex conjugate of this complex number. So what I'm going to do is I'm just going to assign alpha equal to 2 plus 3i, and beta equal to 2 minus 3i. Great, and I still have gamma, which is a half. Okay, perfect. So I've done A and B, that's 4 marks down. Next of all is to find the value of k. So what I'm going to do with k is I'm going to use this other formula that I haven't used yet to help me find what k is. So using the formula, I have to times 2 of my roots together in the 3 different possible ways that I can do that from alpha, beta and gamma. So 2 plus 3i times 2 minus 3i, add 2 plus 3i times a half, add 2 minus 3i times a half. So that's added them all up together when you multiply them, 2 of them in 3 different ways. This is going to equal c over a. So c is k, a is 2, so it's k over 2 this is going to equal. Now expanding the brackets, I'm going to get a 4 plus 6i minus 6i, so I won't write that down, and then it's going to be minus 9i squared plus 2 times a half is 1 plus 3i over 2, but I'm going to get a minus 3i over 2 in the second part of it, so I won't write that down. And for the last part of it, I'm going to get a plus 1 as well. That will get me k over 2. Now, what happens here is I've got a minus 9i squared. Remember, if I is the square root of minus 1, then I squared is going to be minus 1 itself. So minus 9 times minus 1 is 9. So 9 plus the 4 is 13, plus 2 extra ones, that will get me to 15. So 15 equals k over 2. So k must therefore be 30. Excellent, 3 marks for that, 7 marks in total.